Hello everyone. So today we'll discuss one question which is based on AIME, and the question is moreover based on logarithm. But we'll try to learn how logarithm is moreover related to time and work. Means I can say algebra is somehow somewhere related to arithmetic. So we'll directly move to the question here. It's given x, y, z are real numbers greater than 1 and w is a positive real number if log w to the base x is 24, log w to the base y is equal to 24, and log w to the base x into y into z is 12. Find log w to the base z. Right, so before moving to this question, let's try to identify something related to log. If I have value as log a to the base b is equal to t, I have written t in this case, where I have to identify that here this value, the base value, is always the rate part here. This part is always the size, and this part is nothing but the time allotted basically. Right, or else size in this sense I can say work done here. So ideally I can say log is nothing but at what rate I can reach to a particular size on what time frame, or else at what time I'll reach to a particular size with a particular rate. Let's take a normal example here for the time being. Suppose I'll give you the figure as log 8 to the base 2. We know the value is nothing but 3 here. Similarly, I'll take the value as log 16 to the base 2. This value is nothing but 4. We'll discuss about the log part later, but let's try to identify this thing here. Now here you can identify that with a change of rate 2 and I want to reach to size 8, I need 3 hours here. Similarly, to reach to size 16 I need 4 hours. Basically it's nothing but a geometric progression part. Let's try to identify this one in terms of a table. So I'll just mark the values here. Here I'll mark t, and this is a, and obviously below this I'll keep the rate part for the time being. Right, so when time allotted is 1, or else let's say when the time allotted is 0, one, 2, 3, 4, 5, 6 something is there. Right, let's say these are in hours, and the size here and my rate here, which is nothing but b, is nothing but 2 in this case. So now you can identify that presently my size is nothing but 1. Right, suppose my size is 1 presently, and I am gaining my size in terms of multiples of 2, or else I'll multiply my rate is nothing but I'll be double of the previous size here. That means my size here will be nothing but 2. In other sense I can say at 1 hour my size will be 2, next hour my size will be 4, next hour my size will be 8, next hour my size will be 16, then 32, then again 64, and then again 128. Right, why? So here I am multiplying 2 to the previous term. Right, that's the basic condition. In time and work we used to add the efficiency, but here in this case we are just multiplying the efficiency. Let's consider 2 is the efficiency in this case, so I'm just doubling my size in this case. Right, so that's why log 0 is always 1 here, log 1 or else log 1 is always 0 here, log 2 is nothing but 1, right, because my size is increased to 2 on the very first hour. Then similarly I can say log 4 will be nothing but 2 log 8 will become 3, and this process continues. So it's almost same as time and work. The only difference is in the case of time and work, we add the efficiency, we add the people. Here we are multiplying the efficiency, right? So just identify this thing. Here I have considered that log 8 is to the base 2 is nothing but 3. That means if a person has an efficiency of 2 in terms of multiplication, that means in 3 hours he'll be able to finish 8 units, right? So basically 2 into 2 into 2 is my condition. But suppose if I'll consider I want the job to be done in 1 hour, this figure has to be nothing but 8, right? So I can say this figure is equal to 2 into 2 into 2 here. In other sense, I can say now there are 3 people A, B, C are working here with the equal efficiency of 2. Now they'll be able to finish the same job in 1 hour, right? So this is how we represent log in terms of time and work here. So I'll be utilizing the same thing here. Now let's move to the information here. If log x w to the base x is 24, so that means w is the work done here. I can say with an efficiency of x, a person can finish a job in 24 days, assuming, right? Similarly, I can say that w is the work done with an efficiency of y, a person can finish a job in 40 days, and all the 3 are working together, they will be able to finish the same job in 12 days. So in how many days with an efficiency of z they will be able to finish? Or else we can say there is a person x whose efficiency is x, there is a person y whose efficiency is y, and there is a person z whose efficiency is z, right? So I'll just figure it out, also I'll just mark it out. There is a person x, y, z, and all the 3 are working together, x, y, and z. So x can finish a job in 24 days, y can finish the same job in 40 days. With the help of z, they are finishing the same job in 12 days. That's the basic condition given here. So I'll take the values 24, 40, and 12. I'll take down the LCM. LCM is equal to 120, assuming that they are supposed to finish 120 units. That means the efficiency of x is nothing but 120 by 24, or else 5. X can finish 5 units per day. Similarly, I can say y can finish 120 by 40, 3 units, and here x, y, and z together can finish 10 units here. So that reflects z can finish 2 units per day in this case, right? So z can finish 2 units per day, right? So now according to this, if z can finish 2 units here, have to finish 120 units if z is working alone. So if z is working alone, this person will be able to finish the job in 60 days. That in terms of log will reflect log w to the base z will be equal to 60. So I can always consider log in terms of basic time and work. That's all for today. Thanks.